Now it's time to talk about comparative advantage, where we link this notion of opportunity cost with the opportunity for gains from trade. We begin with the definition of comparative advantage and note that the person who can complete a task at the lowest opportunity cost has a comparative advantage in that task. In other words, if I can type 50 words a minute and do math at the rate of 25 words per minute, each math problem costs me 2 words. If we compare my rates of speed with someone who types 6 words and does math problems at a rate of 20 words per minute, then each math problem costs them 3 words. I have a comparative advantage at math problems. My cost is lower. Comparative advantage is what drives trade patterns. In the previous discussion, we noticed that that we grow lots of oranges in Florida and lots of corn in Illinois. That is because of the comparative advantage and relative opportunity costs of those 2 different states in the production of those 2 goods. The person who can complete a task using the fewest resources has an advantage in that task. Suppose we compare 2 people, one who can type 60 words per minute and do 30 math problems per minute. Compare that to person B, who can type 40 words per minute and do 10 problems per minute. Person A is faster at both. They have an absolute advantage in typing and math. What we're going to do next, though, is show that a person A has a comparative advantage in math, but person B has a comparative advantage in typing. Note that person A types 60 words per minute and 30 problems per minute. Each problem costs them 2 words per minute. Person B can type 40 words per minute and do 10 problems per minute. Each problem costs them 4 words. So while person A is faster at both math and typing, person B maintains a comparative advantage in typing. Each word they type costs them few math problems. Person A, each word they type costs them a half a math problem. Person B, each word they type costs them only a quarter of a math problem. Now, the comparative advantage drives patterns of trade. It tells you who should make what, who should produce what. What drives standard of living is productivity or absolute advantage. Who can make the most out of the resources that they have? The societies, the states, the cities, the places, the people that are more productive with the resources that they have are the ones that will enjoy the highest standards of living. It's this absolute advantage, this productivity notion, that's going to drive our incomes, going to drive our levels, our standards of living. But comparative advantage is what's going to decide what we make and how we trade with each other. One thing that's important to notice, in an economy-wide perspective, if we all produce the thing we have a comparative advantage in, this will increase the efficiency of production for the whole society. We also want to note, and we'll demonstrate this going forward, that each person will have a comparative advantage in something. The next thing we notice is that specialization makes everyone better off. What we want to do is produce what we can most cheaply in terms of opportunity cost, and trade for everything else. And what we're going to demonstrate is how specialization can increase economic efficiency for all market participants, not just the fastest or the wealthiest. That specialization in trade can be better for both both the highly productive and the less productive members of society. In less productive states, less productive countries, and things like that. I want to consider a simple numerical example. Suppose that we have a contractor, a general contractor, and a fisherman stranded on a desert island, and they both need to eat, and they both need to build shelter in order to survive on the desert island. And the question we have here is very simple. How should they divide up the task? So the table on the left indicates the rate at which they can build shelter and the number of fish that they can catch per hour. These are small fish, so 10 fish don't go very far. And we note that cost is always measured in terms of a foregone opportunity. The contractor can build 25 square feet of the shelter per hour and catch 10 fish per hour. Meanwhile, the fisherman is not as fast a builder as a general contractor, can only build 15 square feet, but can catch fish at a more rapid rate, at 15 fish per hour. We note the opportunity costs associated with this, that a contractor, each fish they catch costs them 2.5 square feet. All the time they spend catching fish costs them 2.5 square feet per fish. Each square foot costs them 0.4 fish. Right? We look at 25 divided by 10 gets us 2.5 square feet per fish. 10 divided by 25 gets us 0.4 fish per square feet. Meanwhile, the fishermen, 15 square feet an hour or 15 fish per hour, each fish costs 1 square foot, and each square foot costs 1 fish. Now look carefully at these and notice then that the cost to the contractor of fishing is higher. For every fish they catch, they could have built 2.5 square feet than it is for the fishermen. For every fish they catch, they could have only built 1 square feet. So the opportunity cost to the contractor of fishing is higher. The opportunity cost to the contractor of building is lower. Each square foot of the house they build costs them just 0.4 fish. For the fishermen, each square foot they built costs them 1 fish. So the cost to the fishermen of building is higher. What this indicates then is that the contractor should build and the fisherman should fish. So consider the following. Suppose that in a world without any sort of trade, the contractor and the fisherman each spend 4 hours working at each task. If this is the case, then the contractor could build 100 square feet and catch 40 fish. Meanwhile, the fisherman could build 60 square feet and catch 60 fish. The contractor, remember, could do 25 square feet and 10 fish in an hour. The fisherman was 15 or 15. But then if they specialize in trade, if the contractor builds all day and the fisherman fishes all day, if this is the case, then at the end of the day we wind up with 200 square feet being built and 120 fish being caught and the opportunity for gains from trade. If we trade 70 square feet for 50 fish, then the contractor winds up with 130 square feet of shelter and 50 fish at the end of the day. Meanwhile, the fisherman winds up with 70 square feet and 70 fish at the end of the day, and both of them are better off. Now, the particulars of each trade that people make with each other are going to depend on circumstance. This is just one possible trade that shows that they can both be made better off by concentrating in the task that they have comparative advantage in. Now what we want to do is consider a different problem where a fisherman is trapped on the same desert island, but this time with an economist rather than a general contractor. The fisherman spends more time working with his hands and building outside, and so is better at both building and fishing than the economist. The question here is, can they both benefit from specialization in trade? And what we're going to find here is that the answer in this case is yes, specialization is always possible. Right? And the reason for this is that when we think about the opportunity cost of fishing and the opportunity cost of building houses for the fisherman and the economist, is that one is going to have a comparative advantage in one task. The other is going to have a comparative advantage in the other task. So the question that I would ask you is, what should, in our example, what should the economist specialize in? Well, he's not as good a fisherman. He's also not as good a builder, but what should the economist specialize in? So think about this for a second and observe the opportunity costs. Divide the fish per hour and the square feet per hour, and we look at the fishermen, and from the same numbers from the last example, each fish they catch costs them a square foot of the shelter that they could have been building. Each time they spend building the shelter costs something in terms of fish, and given the rates at which the fishermen can build and fish, we see that each square foot costs 1 fish. Now consider the economist. In this case, the economist can build 10 square feet per hour or catch 5 fish per hour, and what this says is that each fish costs the economist 2 square feet, but each square foot costs the economist 0.5 fish. What this then says is that the opportunity cost of building for the economist is lower than it is for the fisherman. Building costs just a half a fish per square foot. This says to us that the fisherman should fish and the economist should work on the house, and both sides can be made better off with specialization and trading. So let's put a numerical example and suppose that each spends half their day 4 hours fishing and half their day 4 hours building. In this case, the economist winds up with 20 fish and 40 square feet, And the fisherman winds up with 60 and 60. Now note carefully that the fisherman is going to wind up better off than the economist. Remember, the fisherman has an absolute advantage in both tasks. The fisherman will be, in some sense, richer than the economist. They're better and more productive at doing each of the tasks. This doesn't mean that they can't both gain from specialization and trading. So the following example that shows a scenario where they can both benefit. The economist, we said, should build, and so we send the economist off to work on the house all day, and the economist can generate 80 square feet for the shelter. The fisherman can build 30 square feet in 2 hours and fish for 6 to catch a grand total of 90 fish. Now note where we're left off. We now have a situation where the economist has built 80 square feet, the fisherman has built 30, so we have 110 square feet of house. This is more than we're working separately. We also have 90 fish captured in the 6 hours, which is more than the 80 we had when they were working both separately. Now we propose a trade where the economist sends 35 square feet to the fish in exchange for 25 fish. And we wind up with a situation where the economist has 25 fish, the ones they received in trade, and 45 square feet for the shelter, the 80 they built minus the that they traded to the fisherman. The fisherman winds up with 65 fish and 65 square feet, which is better than the 60 fish that they had when he was working alone. The key point here is that trade can be beneficial to both the highly productive fisherman and the lowly productive economist. So what we say here is that small countries can benefit with big countries as a way to extend this to thinking about things like international trade. That trade has the capacity and the potential to make both sides better off. A couple of brief definitions before we wrap up our discussion here, and the first thing that I want to define is imports. An import is a product that is produced abroad and consumed at home. So imports are things that we import from other countries. Exports are products that are produced here and consumed abroad. These are things that we send to other countries. Now, we import the things that we produce at high opportunity cost. If our opportunity cost of production of something is high, we're better off importing. We export the things that we produce at low opportunity costs, right? We export the things that we can produce more cheaply than the rest of the world in terms of opportunity cost. So we trade for the things that are relatively expensive for us to produce, and we sell the things to the rest of the world that are relatively inexpensive for us to produce. To sum up, productivity, absolute advantage, determines how rich a person or country is, while relative opportunity cost, comparative advantage, determines what they specialize in.